Early ideas about galaxies. When people first saw galaxies through a telescope, the view through the telescope was essentially a little fuzzy spot. It didn't really have a lot of features, and they had no idea what it was they were actually looking at. So it left the door open for a lot of different ideas. In general, they were called gaseous nebulae. Nebulae was basically anything fuzzy in the telescope. And these appeared to be made of gases, so gaseous nebulae. Now, two different people came up with two very different ideas. The first one, Harlow Shapley, he's the one who determined our location in the Milky Way, and subsequently how big the Milky Way is. And he said these must be star-forming regions. And one of the reasons he thought that is because he found that our Milky Way is about 100,000 light years across. And he couldn't imagine anything bigger than that. So he thought our Milky Way was the entire universe. And so these were just regions where you had gas clouds collapsing down and forming into stars. Heber Curtis thought that these were not part of the Milky Way. He used the term island universes, but basically outside the Milky Way. So like the Milky Way, but their own distinct entities beyond the Milky Way. So he pictured the universe as lots of these little things, and we just happen to be inside of one of them. Now there was a large debate between Curtis and Shapley, and appropriately enough, it was called the Great Debate. And they both presented their hypotheses and their reasoning behind each. Not a lot of observational evidence for either. And really there was no conclusion that came out of that. Some people sided with Curtis, some people sided with Shapley, but there was no consensus on what these nebulae were. Until Edwin Hubble came along. Edwin Hubble had access to a very large telescope, and the unfortunate name of Hooker. The Hooker telescope at the time was the largest telescope in the United States. I'm not for sure in the world, but certainly within the United States. It was in Southern California at Mount Palomar. And he took images of what was then called the Andromeda Nebula, because it was one of these gaseous nebulae. And because the telescope was so large, he was able to get very good images to the point that he could see individual stars. And among those stars, he identified Cepheid variable stars. Now recall with Cepheid variables, they vary in brightness, and that period of variability is related to the luminosity. So that means he could observe these Cepheid variables, and here you see VAR exclamation point. That was one of the variables, and so somewhere between those two hash lines is the star. So he took images every day, got that period of variability, which he then used the period luminosity relationship, got the luminosity. Then he could compare it to the apparent magnitude to get the distance. And so he was able to calculate the distance to this Andromeda Nebula and found that it was beyond the Milky Way. If the Milky Way is 100,000 light years across, it was farther than 100 light years. Now, it turns out the number that he actually got was wrong because they didn't realize there were two kinds of Cepheid variable stars. And so there's a slightly different period luminosity relationship than the one he used. But regardless, he definitely confirmed it was not in the Milky Way. We now know that Andromeda is about 2.2 million light years away. Which sounds really far, but that's actually the closest large galaxy compared to our own Milky Way. So his observation finally settled the great debate. It was no longer debated, it was no longer a hypothesis, it then became accepted theory. There are galaxies beyond the Milky Way. So Edwin Hubble is the one to thank for understanding that our Milky Way is not alone in the universe, that we are one of billions of these galaxies that make up our universe.